All right, well, we all survived the winter, what do they call it? The vortex? Polar vortex. It was a wicked polar vortex. Um, yeah, it was gnarly. So, good to see all of you. It didn't freeze out there. All right, so this whole chapter is about fractions that have polynomial numerators and denominators. So you know how like students always complain about fractions, like, not fractions, oh no. Well, guess what? Now they're fractions with polynomial numerators and denominators. Yay! It's kind of like I've told this little joke all day, but do you know how the Teenage Mutant Ninja Turtles were born? And they that like green ooze spilled on them, and then they turned into like big teenage mutant ninjas turtles. um, so this is kind of like that green ooze spilt on some fractions, and then these fractions like no, it's funny. I mean, it is fun. It's funny. Okay, good. All right, so what we're gonna do is simplify, and we're going to multiply and divide and use, we're going to solve equations with these in them. So here's some stuff from the book if you want to read that. There's definition. We'll get started. So when we simplify any fraction, I'm just going to get a different, I'm going to get a different page here. I'll just go down. Well, maybe this. Yeah. So let's just say we have some fraction. Let's say we have like 12/20ths. Can you simplify that fraction, or is that in lowest terms? Can. Okay, you can simplify it. And so you can simplify it because they each have a common factor of 4. So if I rewrite this, I could rewrite this as 4 over 4 times 3 over 5. So 4/4 times 3/5, right? And that's the same as 12/20ths. So I'm thinking backwards. So if I do this problem and I say 4 times 3 is 12 over 4 times 5 is 20, it's the same equivalent fraction. But 4/4 is the same as what? 1. So this is really 1 times, 3 over 5. And so 1 times 3/5, that's the same as what? Just 3/5. So really, this is 3/5 is the same as 12/20ths, right? And so we just kind of factored out that unnecessary factor of 4 over 4, which is really just a 1. Okay, so we're going to use that concept when we are simplifying these polynomials. So if we go back to the first page here, we have the rational expression 16x to the 11th over 8x to the second. If I rewrite that with some common factors, the common factor of 8x squared, that would be the same as 8x squared times 2x to the ninth over 8x squared times 1, right? And then if I break that apart, that's really the same as 8x squared over 8x squared times 2x to the ninth over 1. And you can see that in there is a factor of 1 that is really unnecessary. We can just take all that and just ignore it and get rid of it. And so we simplify that to be the same as 2x to the ninth. No one really writes over 1, do they? No, that's just ridiculous. It doesn't say 24 over 1 on the back of your jersey, does it? Now, if I were doing that problem, I wouldn't necessarily write out all those steps. I would probably just look at it and go, okay, they each have like the coefficients 16 over 8, they both have a common factor of 8, so that means there's a 2 left in the top, right? And then x to the 11th over x to the second, there's 9 extra factors of x in the top, so 2x to the ninth over 1, that's just 2x to the ninth. And that's, I probably would, if I was doing this problem as a student, that's how I would write it out. But as a teacher, I'm showing you all this extra behind the scenes. This is how it actually works type stuff. Okay. Now, if you watch the boring, monotone gal's video who Aaron thinks I only picked the video because this gal was pretty, which really is insulting to me, Aaron. Thank you very much. I thought she did a good job of presenting the material, and that's why I picked the video. And it was actually neat how she writes on the, I don't know how that trick works. That was pretty neat. But anyway, if you did watch that on our digital learning day, you would have remembered the part in the video where she says, now, I would be, what did she say? Let me think about it. It would be irresponsible of me to not mention this right now. And so, yeah, see, now you remember that part. So the irresponsible part is when you have variables in a denominator, you have to be careful that your denominator is never equal to 0 because you cannot divide by 0 is undefined. So anything that makes a denominator 0 is off limits as far as the domain or any possible values. So in this case, x, ooh, that's not a good color for that. X, like this one, x cannot equal what value that would make the denominator 0? 0. Good. So you have to state your values that the expression is undefined. That's what this means in the directions right here. Okay. 1b is a little more fun. 1c is even more fun. I'm just going to make a mention of something right now. This is very important. This is a very common mistake here. Students will very commonly get like canceling happy, and they just look at, like in 1c, they just look at this and go, all right, simplify this. Oh, cross that off, cross that off. But you can't do that. That's against the rules. You can't cross off terms like that. You can only cross off factors. That's why we had to rewrite this stuff over here in question 1 as like the product of 8x squared times 2x to the ninth and so on. So you can't do that. Here's a simple example of why. What if you had 2 plus 4 over 2? What's the value of that? 3, right? You can't just go and cross off these 2's and say it's 4, can you? It's not 4, it should be 3. So you change the value of it if you cross off terms like that. That's against the rules. So you can't just go for this one here and go, oh yeah, that 3x cancels out 3x there and leaves an x. You can't do that. So if you're thinking about that right away, that's not going to work. All right, so we have to factor the numerator and factor the denominator and see what common factors we have. So we cannot cancel terms. You can't just cross off terms. And terms are added and subtracted. Factors are multiplied. Anything factor in this numerator in 1b? Nope. So I just have 3x plus 4 there. And in the denominator, I should be able to factor. Now this is where you got to be a little smarter than the math book, right, Dylan? And so I bet you that this factors as 3x plus 4 and something else because it's the simplifying part to the book, see? So you got to be able to play the game within the game there. So I bet you that's a plus 4, and I bet you that's a minus 1. And if I check my outside products, let's see what I get. Negative 3x, and my inside products, I get 4x. And do those add up to positive 1x? Ding, 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 ding. Okay, good. So I checked it. It works out. Now I can go ahead and simplify any common terms. So right here I have a common term of 3x plus 4 in the top and the bottom. I said term, I should have meant factor. Go back and cross off any common factors in the numerator and denominator, so 3x plus 4, those can go away. So I'm left with 1 over x minus 1. That is equivalent to, that's exactly the same as that expression up there.
So you can only cancel it if like the product isn't like in parentheses, like it's its own, like on the bottom. How, like,
yeah, Yep, you can only cancel it if it's in, she asked, because if it's in parentheses. And yeah, that's a good, like, basically general rules to say, yeah, you want to make sure there's parentheses there before you start crossing stuff off. So like right away, it might be a good idea for some of you just to go, all right, let's just do this. So I know that that's like one whole factor there. That's not, these are all individual terms. Like that's an individual term, that is, you know, you can't just cross those off, right? So when we did like, if we did 10/15ths, okay, and we changed that and we said, okay, that's the same as, watch, I'll go like 5 plus 5 over 5 plus 10, right? That's equivalent, isn't it? What I did. Now, can I just cross off those 5s now? Can I just go like this and say, oh, it's 1/2? No, it's not 1/2. You can't do that. All right? But if I went the other direction and I said 10/15ths, that's the same as 2 times 5 over 3 times 5, and now they're multiplied. Now, I didn't use a parenthesis to indicate multiplication, right? But I could have if I wanted to. Now you can cancel those off because they're factors. It's a common factor. It's the same as 2/3 times 5/5. But it's just harder to recognize that because we're dealing with polynomials here.
If there's like a 3, like, on the top in front of the parentheses.
Like if there's a 3 right there,
Yeah.
that's fine. Then it would just be 3 over
Oh,
x minus 1. Yep. But here I crossed everything off, so there's always the invisible 1, right? 1 is always a factor. We just don't write it there. All right. Good job. High five on those good questions. All right, next one is just a little more fun because we have trinomial numerator and denominator. So this one unfoils and you're going to get some good times with the canceling going on here. So I'm going to pause it and make this video less long. So we saved a little time. We got this factoring set up. And so 3x and 2x, I think this is the way we go. Factors of 2 are going to be 2 and 1. So I'm going to put the 2 with the 2 to make 4 and the 1 with the 3 to make 3, and I add everything. And that should give me what I need. 3x plus 4x makes 7x. Yep. And then over here, I bet you one of these is going to be matching up. So let's go 3x and I bet you it's a minus 3 that makes the negative 9 and a plus 2. Yep, that's negative 9x and 4x make negative 5x. Ta-da! So factor that. Hopefully you're pretty good at factoring trinomials. It's a skill you need to be able to use now in these higher level chapters and classes. Basically anything past Algebra 2, you're going to need to be able to factor well. Those two factors cancel out, and we're left with 2x plus 1 over 2x minus 3. And we have some restricted values. We kind of forgot to do that on the last question, didn't we? So on the last question, x cannot equal 1 or negative 4/3. And people forget about the one that got canceled, right? Even if you cancel off a factor, you still have to consider that as a restricted value for x, or a domain restriction. Same thing over here. X cannot equal negative 2/3 or positive 3/2. Okay, so watch out there. Next page, we have this little factoring out -1 trick. So sometimes you're factoring an expression and you almost can get something to cancel. Like in this case, if I factor out a 5, I'm left with 2 minus x. Wait a minute, 5, 2, dummy. Oh boy, they're always after me, Lucky Charms. So factor out a 2, I'm left with 5 minus x, and then that's over x minus 5, and I'm thinking, well, man, like, that's not the same thing, but it's almost the same thing, right? Because you can't just switch minusing around. It's not commutative. But if you factored out a -2 instead, so if I change this top part and I factor out a -2, then watch what happens here. Factor out a negative 2, I'm left with negative 5 plus. Just kidding, negative 5 minus. Yeah, it is plus x. Okay, and then, oh, negative 5 plus x, that's the same as x minus 5, really, if I switch those around. So, bada bing. So now I have negative 2 times x minus 5 over x minus 5. So sometimes when you factor a negative out, it just switches the binomial stuff around, and you are left with something that will cancel out. So that's just equivalent to negative 2. Okay, pretty neat, huh? And then identify values for which expression is undefined, so then it cannot equal 5, right? Because if you put a 5 in for x, guess what happens? You get a 0 on the denominator. All right, same little problem in 2b, factor a negative out. I'm going to skip that one for time's sake. Move on to multiplying. So now we're going to multiply these fractions and divide them. And so sometimes when you're multiplying, like if you have a bunch of monomials here, this is actually easier to put it all together and then simplify it rather than simplify it first. So, and I do have to mention something. One student just said cross multiply, and it's very, very common for students to see a couple fractions and automatically think, oh yeah, cross multiply. But you only cross multiply when there's an equal sign. Okay? So it's very I know you did so many of those questions when you were little where it's like cross multiply divide, cross multiply divide. And it got it so ingrained in your memory. You see two fractions, you're like, oh, cross multiply. I remember how to do that. So I don't blame you, but you have to be careful. That's why I don't even like cross multiply it's too catchy. You almost use it too much. So I like to use cross products. So use cross products only when you have an equals. But anyway, if you multiply fractions, you just multiply the top stuff and the bottom stuff together. So if we do that here and we take all this top stuff and we make it 1 because it's a bunch of monomial stuff, I'm going to be left with 20x to the 8th over the bottom stuff now is going to be 30x to the 5th. And so if you have a bunch of monomials, it's actually easier to multiply the stuff out first and then cancel it. So now you can see, because it's just a monomial over a monomial, you don't have to worry about accidentally crossing off a term because nothing's being added in the numerator or subtracted. Same thing in the denominator. So like here I have a common factor of, if I look at 20 and 30, they're both divisible by 10, so that would be a 2 and a 3. And then I have 5 x's in the denominator, canceling out 5 of the 8 there, leaving 3 in the top. So this whole thing ends up being the same as 2x to the 3rd over 3. And then for this one, they give us a little break on undefined stuff. They just say assume all expressions are defined, so you don't have to worry about x not equaling. It's still there, but they're just giving us a break on having to do that part. Okay, so if you have monomials, a bunch of monomials, sometimes it's easier to just multiply them all together and then simplify it. But if you have like binomials and trinomials and stuff like that, it's easier to simplify first. So in the next one, I'm going to factor and simplify what I can before I multiply. So that top is going to be 10 times x minus 4 over unfoiling the bottom here is going to give me x and x, 2 factors of 8 that add up to 6, or minus 4 minus 2, like that. And then that's times x plus 3 over there. I'm going to put parentheses around that just to keep things nice and organized. And then I factor a 5 out there, and I have another x plus 3 like that. So now if you have like a bunch of binomials and that type of stuff, it's way easier to factor stuff and simplify it before you multiply it all together. So let's get our samurai sword, our math scalpel out, and let's start crossing stuff off. X minus 4. X minus 4. Those cancel out. X plus 3 here. Jump, jump. 10 over 5, those can cancel out. 5 and 5, that becomes a 2 right there. So really, all said and done, what I have left is 2 over x minus 2. And then there would be a bunch of restricted values, but it said not to worry about it, so I'm not going to worry about it. Question. I'm going to pause for question. All right, we're not in Kansas anymore, are we? So dividing is the same as multiplying by the reciprocal, so it's really not that much different. You just have to take the expression after the divide and flip it. And then now it becomes the same thing that we just did on the previous page as a multiplication. So before you go dividing anything, just change it to a multiplication problem. So this one becomes x squared over 4 times 12y squared over x to the 4th y. And then now it's just the same exact thing we did on the previous page. Like I was just saying earlier, if I have a monomial stuff times like more monomial stuff, I have a tendency to just put it all together as one monomial. So this is going to end up being 12x squared y squared over 4x squared x to the 4th y. I just think it's easier just to get it down to one monomial over the other monomial instead of like cross this off, cross that off, cross this off, cross that off. Like that just gets to be annoying and kind of messy. So I go against simplifying before I multiply on that one. So now I simplify after 12 and 4, common factor of 4, so that leaves a 3 up top. X squared and x to the 4th has 2x factors left in the bottom. And a y squared over y means there's a 1y left in the top. So what I have left here is 3y over x squared. Yay? Assume all expressions are defined so we don't have to write what x can't equal, even though it can't equal 0 and y can't equal 0. All right, last one here for dividing. This one, a little more fun. Got some trinomials, some binomials, some difference of squares in here. So I'm going to rewrite it first. I'll be thorough on this. Which one do you flip? The first one or the second one? The second one, yeah. So 8x squared minus 28x plus 12 is on top, and 4x squared minus 1 is on bottom. So I have a couple difference of squares here. I have a couple unfoils. I should have a bunch of binomials over binomials. So on the bottom here, I'll do the easier stuff first, x plus 3, x minus 3. You know, you do the easier stuff first too, because then you end up being able to like be smarter than the math book, you know, and be like, oh, if 2x plus 1's a factor down there, maybe it's a factor up here, see? And then you can just give yourself little hints. So like this one over here, this numerator is going to be 2x and x. And then minus 4, that could be a 2 and a 2 or a 4 and a 1. I bet you it's a 1 because there's 1s on the right on the bottom side. So let's see if I go, if I go minus 4 there, that's going to be a negative 8x. And if I go plus 1 there, that's going to be negative 7. So there we go. And then over here, I forgot this all 3 times today. I forgot to factor out the 4 until now. So factor out a 4 out of this stuff, right? So if I take a 4 out of that stuff, I'm left with 2x squared minus 7x plus 3. And it's just a little easier to unfoil that. So take that 4 out, unfoil the 2x stuff. I'm going to have 2x and x. And then I need 7 in the middle, so it's going to be a minus 3 like that and a minus 1 like that. Negative 6 plus negative 1. Bada bing. Now is the fun part. I can do my Fruit Ninja. So I can take my Fruit Ninja sword and go, yay, yay. I can take this one and go, Sudoku. Cross those off. I can do my Mortal Kombat and go, get over here, and cross that off. I think that's everything. So now in the numerator I have 4 over x minus 4, and in the denominator x plus 3. Gonna get a complaint. My Mr. Bolio is making references to violent video games in his videos. That's a long one, I know, but you can fast forward. So last page, everybody. Last page. We're going to solve equations. The only thing I'll say, you've done these before. This is where the cross multiply comes in, the cross products property comes in, because in any two ratios, if you have A over B equals C over D and they're equal, then you know that A times D is equal to B times C. That's the cross products property. So in this case here, -7 over 1, you can cross multiply, and you can use your cross products property to solve that. You can also simplify and solve it that way, but here's the one thing I want to say about this. You have to be sure to check your solution, because there are restricted values here. What's the restricted value for x? It cannot equal -4, yeah. So if it equals -4 and you solve it and you get -4 for your answer, you know what that means? It's actually not a solution. It's technically, they call it an extraneous solution. Extraneous, bogus, trickin', whatever. So it's not really a solution. So in this case, you'll see that happens here. So we have x and x. It's a +4 -3 scenario over an x plus 4, and that equals -7. These cancel out. I'm left with x minus 3 equals -7. You add 3 to both sides, and you end up with x equals -4. And then you're like, yeah, dude, I got the answer. Cool, all right, circle it. But really, bud, you got to check your solution. Don't forget, -4 is extraneous, bud. So it's really not a solution. This is actually a bogus solution. Okay, it's extraneous. So now what is the solution? No, 0 is a number that would make the equation, 0 is a number for x that would make the equation equal something. So if I put a 0 in there for x, I would get -12 over 4, right? Which would be a -3. And does a -3 equal a -7? It's a horrible negative sign, but or 2 negatives. No, it's a big long 7 is what it is. So 0 doesn't make it true. So it's not 0. What else? What would the solution be? Kate, what do you think the solution would be? No solution. Yeah, there isn't any that work. Sorry, there is no solution. Try back tomorrow. Maybe we'll have a better equation for you with the solution. All right, not bad. Under 30 minutes, okay? So if you're watching this video, you might be sleeping by now. So wake up and rewind some of it to the good parts. All right, ciao.